Right, so just taking lunch. I'm going to set myself a 1 hour timer for lunch on my lunch break to essentially build this web server from scratch, calling it Fabs, full stack C++ application banking system, just because it sounds cool. I'm building the entire library or the entire full stack in C++ only using standard libraries. The front end, first thing I'm going to build first, this I can build really quickly. The important bit that's the most compute, obviously, is the web server and the REST API. To display the static images or dynamic pages, whatever, it will be HTML, CSS, and JavaScript, which keep it plain. We're more worried about the backend infrastructure, core code, really, like the infrastructure, which is the web server, and the REST API, which really is just the web server. So these are technically one thing, right? That's besides the point. So the database, we're going to use SQLite, and then this can just be plain vanilla HTML, CSS, JavaScript. Currently working on the web server. So the web server breakdown, let's make sure my music's muted. Yeah. So the web server breakdown is a client makes a request to the web server. The request handler parses the request and forwards the routing module. The routing module determines whether to serve a static file, blah, blah, blah. If static, return the files and everything. So the actual core modules are a connection manager, so accepting client connections. Actually, I'll do a review of this actually. So we have our socket code here. And as you can see, we've just used standard library functions that come with the client compiler or normal C++ standard lib stuff. What we have is we have a start server socket, which starts the server, and it reads in all this code here essentially is to create the socket, specifying the local address, to build the socket, and then we bind and accept any connection requests, right? And so we listen, and if anything does happen from this, the client socket will accept whatever information that's come through. So the server address it can come from any IP address, and once we receive the buffer, I think it's 16 kilobytes. We receive it, check the size, and assign this to buffer, right? And then what we can do from here is just print out the message from the client. And what I've also done here is I've just parsed the HTTP header. And yeah, so I'll talk about that in a bit. So we do have a start server socket, and then we have a client start client socket. Same thing really, socket stuff, except all you need to do for this is you need to send out a connection request. So you just send out the connect function, which again, this is standard library WebSocket stuff. I will build my own WebSocket standard library in the future, but this is first parse, right, of building this. And we send the data message. In this case, I've just sent a HTTP request, right? So saying patch, it can be anything, it can be get, for example, right? And then we print out that the client's in data, and then we actually send the data through. So this would probably be a better orientation, right? And the same for this part up here, right? Oh, and we'd actually have to do this. Cool. So we know how to start a socket, right? We know how to start a server socket, and we know how to start a client web socket, right? And we can pass messages to and from each of them. That's great. So we have the first bit done, right? Which is the accepting client connections and sending messages from client to server, right? This is great. The next thing we need to do is pass a HTTP request handler. So this parses the incoming HTTP requests, right? So what we have is a function called HTTP parser, and all this does, again, you're just using standard libraries, right? Is when we parse the HTTP header, we read the HTTP request that's sent through, right, as a stream. We convert it over, and we read the first word of the stream into the method object or the method string. And then we have an unordered set of get, post. So these are all the valid headers you can have in an HTTP request. And then if the method is valid, return it. If it's not valid, return a valid method. That's kind of how it works, right? So I can run the code and show you. So if we run the code, we have a starting application, and we have multi-threading set up. I think this is a good way to have the threading. We just have two threads really, and they merge at the end. Start the server, detach that thread, and I have a client thread started, and that joins in back to main, and that works, right? So start the application, start the server, client, send the message, listen, and client sending data, and then we return method get, right, which is true, because if we check the test parse, which should be get, but we actually hard-coded this, so we didn't need to test parse, right? If you check the client's information, the client sends the data of get, so that is true, right? And then it stops the application. So we've done the connection manager, right? We've done parsing of incoming HTTP requests. Now we need to send basic HTTP response. So I need to work on this, right? This is what we need to work on. There's some things that I need to rework, which I'm now looking at after I've reflected over my code. We only accept incoming connections, but we don't. We can parse, but we need to response, right? So we need to send a response socket back. And in order to achieve this, right, the response generator. How do we achieve this? Well, the first thing we need to do is we need to be able to, from server to client. And what are we sending? We are going to send a response header of response header, right? This is all we need to do. I don't know how to do this, so we're gonna have to figure it out, right? I have no clue. I'm doing all this for the first time. So when we have a server respond to the client, I'm just gonna turn the music off for a second. Response generator sends basic HTTP response, and then the routing engine maps and then serves a static file. So we need to send a basic HTTP response first, and then these can chuck into this response. So this is more like a sub thing, right? More looks like this, if you really think about it. So you have to have, I mean, they're all sub of each other because you have to have a connection manager to set up, so that's actually okay. Cool. So dev in progress. Send basic HTTP responses. So if we look at our code, once we establish the socket connection, right? Let's have a look. So the client can send information, and we just pass send the client socket, the message, and the string length of the message, and 0. I wonder if we can do it this way, right? And if we need to listen on the, I'm gonna try the code once and then we'll have a look at a guide or tutorial, but I'm just gonna try to do it myself. So from the server side, we listen to any incoming connection request, we receive the data, and then we parse and print. But what we also want to do is we want to send out the data back to the client, right? The client will probably have to have some sort of listen function as well, listen to the assigned socket and send it out, right? So in this case, send out the client. So this is a to-do. We need to send out the client back to the, send out data back to the client. Send a message confirmed and received, right? And for here, once we send the data, we also need to have a listen, right? So let's set it to do. We need to listen to the socket and print out the data that is received. I'm going to attempt to do this myself, could be wrong. I'm just going to piggyback off of the send and listen stuff. So what we need to do is send a message that's confirmed and received, right? So I'm just going to copy the code from here, send the client socket. So we're going to send. Now we're parsing the send function, right? And if I'm just going to double check, this is coming from where? From here. So you send int, pass an integer, a constant void pointer, the size, and the int. So let's just pass this by here. So I know what types we need to pass through. And the client. So we're going to send. We need to pass an integer, which seems to be the client socket, which, right? we need to pass through a message. So I'm gonna write a message called, it can be anything really, to be honest. So I might just set this string. I don't know if we can pass strings, so it might have to be the traditional way of defining a string, which is a pointer array of multiple characters, and I'm going to call it received message, all right, or return message. And the return message can look something like message received. So we can say the service, so message received from you. Message received from you. Right, just do something like this. Alright, message received. Why is causing a plus? Type can be replaced with an auto. I won't do that for now. So we have a message, right? So we can pass through our return message and the string length of the return message, and also pass 0. Now I wonder if this will work, right? Because this is going to send out a message, right? But we need to have, I don't think the port is going to be listening on the client side, so I'm assuming we have to listen, right? And do something kind of like this, right? So we listen to the socket, accept any connection request, and then receive the data. So I'm assuming we have to do the same thing for the client side, right? That's just my guess. I'm going to run this as of now and see if we return anything. Client send in data, message received from you, and then I'm going to print something here. Send a message sent, received message sent out. Kind of something like this, right? Method get. So we actually don't need to parse this really, which we send here. Yeah, so the socket stuff setting up, and then we have a message sent out, and then that's it. So we need a way of receiving the information, right? So we need to have a way of receiving information. So we send the data to the connection request. We should probably listen to the socket, right? Which looks something like this. So you send a listen. I'm not sure what 5 is. I think that might be the type, like TCP maybe. But we can copy this code. Once we send out the data, and or it receives the data, right? So once we send out the data after it's been connected, we need to listen to the socket, right? Place this with the client socket. Int, oh. So we're going to listen to the client socket. We can accept any connection request. In server socket, in server, so we're just going to place client with server in this case. Message received from the server, print out the buffer. Now I hope this works. We should probably print message from the server is nothing. Let's just double check this code again. So if we split vertically, and let's just try this again. I will rewrite this from scratch. So if we jump up to server socket, we listen to the assigned socket, we bind. So I think we already bind it up here. Let's try to implement it ourselves and see how far we can get. So we listen to the socket. Client is going to say listening to the socket, right? And then we need to parse the listen to the client socket. So the socket, then we accept any connection. I'm going to say int server socket is server socket accept any. The server socket is anything that's accepted from the client socket of, and now we need to cast types, right? So we're going to cast this, whatever the sock address is. And then we pass it null. So the server socket, or the server socket now set up. And we're going to receive the data. Char buffer, something like this, right? And say receive the server socket buffer size of the buffer, pass in 0, and we can also print something out to say, hey, we've received your stuff. From the client, we can say message received from the server, pass in the buffer, and chuck in a nice little break line. So hopefully that should work, right? Because we're sending a return message out to here. I might have to put in artificial wait to make sure the server socket is set up first, because it splits out afterwards, but I will wait and see. Client message received from the server, and then we have received message sent out, stop by application. What I might do is have a look at some code as to what's happening, right? I haven't used the the Clang debugger on Mac yet, so we can give it a try. So what is the received buffer? What is this? If we run debug, will this work? Sure. What is the message? Okay, but what's debug though here? Jump through. What is the buffer though? Server address, don't really know what any of this is. The message. What about the return message? Server socket equals accept any of the messages, and if it's true, the buffer, what's the buffer set to? Set to nothing. Get the message, but the message is what we're sending out, right? What about the char buffer? It's initially set to 0, which I can understand that. The buffer set to nothing. You did assign it to nothing, but it must not be receiving anything, because that makes sense. We assigned to nothing. The receive server socket buffer. Maybe I haven't done this properly. The receive for not the buffer client socket. Let me have a check. I might parse this through Claude and see what we can get. How come my client socket is not receiving any data? Preventing it. Ah, okay, because I'm not using the right function. That makes sense. Cool. So we're learning, right? There are several problems with the client socket implementation. There's no receiving data. Let me explain. TCP client, so the server model is in the client center. You're trying to use listen and accept, which are server-side operations. The client doesn't listen for connections or accept them. It only connects to a server. Incorrect receive logic. In your client, you're trying to receive data from server socket. This is incorrect. Here's a correct division of start client socket. Change receive. So we send the data, which was fine. Now we just received, which is, you just provide a buffer and the received side. What does this function do? We should probably check, right? So we'll type in CPP, socket, receive V. What does it mean? Receives a message and connection load socket, usually with connected sockets. So instead of all this waffle, right? All this bloody waffle, we don't need none of these. Let's run main. And then that doesn't work, right? So let's restart. This should work. Received message, sent out, blah, blah, blah. Cool. And let's just print out what the return message was. Receive the data. What about in test threads? Return message, we send the message back out and we print return message. Received message sent out. Message from the client. It's because this is bugging out, this won't work, right? Receive connection request, sending the data. Especially if you're just sending connection requests, sending data. Let's go back to this, which we need to have a recheck. So what's the way we're supposed to do it? So client function started, create client side socket. So this is the code we had before, sending connection request. We've had this before. So then from the client, we can send message, right? So we had this code, which is fine. So send the get request, right? Which is cool. Now, in order to receive a response header, we just used to receive. This is very interesting. Does this work? Server socket. Interrupted by signal, sig pi. Go again. If I debug this and we debug the buffer and this, received message sent out, stopping client. the message should be a return message received from you. Server address the message to be sent. That's cool. Resume program execution. The buffer is still set to nothing. I don't know why. Sure, it's set to nothing, but what is the client socket for is received to whatever? How do we print out the buffer then? From buffer, unless if we just surround it so we know that it's nothing, right? Message received from the server. I think we need to add some artificial weights for the threads. I also have consider adding a timeout for the receive operation. I have receiving any messages. Is it due to my threading? Implementation to customers. Start a new prompt. What's going on? Why am I not receiving any response message from my client socket? Thread ordering issues. Your client started after the server, but due to the way you're using detach and join, the main threads might exit before the communication completes. Closing sockets, no error checking. I want to see what the implementation for my test threads. Test threads. So they sleep the threads, right? Thread ordering, missing socket cleanup. So the only actual issue is the threading, which makes sense, right? Which we thought it was something like this. So what they've done, what Claude's done, is they start the application, start server first, and then so start the server, allow it to sleep. Then for the thread, allow the client thread to start and then join them. Let's see. It worked. Amazing. So we had a threading issue. So the code implementation was right. So we just have to receive. So with this WebSocket library, you just use something called receive. You don't need to bind it because you don't need to fix the socket, right? It just returns. So we have something like this. I'm just gonna draw this for myself. So we have the server socket, and then you have the client socket. This fixes a port. This fixes a port. Something like this. And the client port looks like this. So it establishes, or the server has an open port. So it has an open port. The client goes, makes a connection, TCP response confirms, right? And I'm pretty sure this is done behind the scenes anyways, between the library and TCP IP should do this. And now the connection, right? This is the connection between the two sockets. The client sends something saying response header or request header, request HTTP. The server sees it, and then the server then makes a response. So this is actually the client. And the server sends a response of message received. Which is great. So this code is what we've done. So we jump back to TLD draw. We have finished the response header, right? Now what we need to do is have a response generator. So what we're going to do, because the code works now, I'm just going to commit this to the repo and identify that Claude helped us with this. Don't parse just yet. Done the to-do. Send a return message back to the client. Cool, I'm quite happy with that. Let's just add everything. Do we need to? Let's just add our main.cpp socket. Should bugger out all of it. I can't be asked to check this now. Commit message. Added socket receipt. Server client send response and client feature to receive message from server. Might just hide this quickly. Let's hide the, actually, there you go. Quick authorize. And the pushing was successful. Cool. So something I did actually want to review is the threading, right? So we start the thread, right? So the thread server thread starts calls this function, then this thread, STT, this thread, sleep for a set amount of milliseconds. How does this thread know it's referring to this though? Because it's one thread at the minute. I'll have to look into that. Actually, let me just do this. Can you explain how this thread knows to sleep the server thread? The main thread is server thread. And starts executing star server immediately in a separate thread. The server thread and starts executing the server function immediately in a separate thread. This main thread, not the server thread. then executes this. The main thread sleeps during the sleep period while the server continues running plainly, or it calls listen after the main thread wakes up. It creates a client thread which attempts to connect. Can you draw a diagram of this, please? Can you draw a mermaid diagram of how the threads work? My guess it's something like this, right? The server thread is created and starts executing the start server socket function. So we have a main thread which calls the start server socket. Start server socket. Executes this and sleeps. For 100 milliseconds. Oh, this runs independently. And then after 100 seconds, 100 ms, it starts the client socket, and there's a 10 ms delay where this is 0 ms, or give or take, not really. I see. That actually makes quite a lot of sense. Cool. So you still have a single thread, and that makes sense. And my idea is to just choose the thread, but you actually need to have a starting thread, right? You need to have a parent node of the tree before you separate it out to the child ones. And I'm assuming it'll just continue to do this, right? And I wonder if you can specify to do subthreads. Who knows? We'll look into this. It's quite interesting. This thread was dangerous for the current executing thread. Whatever the thread is running the code. In this case, it's main thread that is sleeping, not either of the spawned threads. This gives the server thread a head start, ensuring it is time to initialize and start listening to the socket before the client thread attempts to connect to it. Without the delay, the client might try to take force connect before the server is ready to accept connections. Awesome. I love that. Here we go. So we need to do another set of code reviews. So we actually updated the test thread, or test thread function. So we have a main thread, right? Already. We start a server thread. We sleep the main thread. Start the client thread. Join both of them and wait for completion for both. Stop the application. There we go. Let's review the socket stuff. Cool. Love that. Cool. Let's run some tunes. So we know how to send a response back, right? Instead of sending a response back immediately, what we'll do is when we receive the data, right, we should parse what the header is. parse what the method is and what the return, what are we returning, right? Maps URLs to handlers. What does a routing engine mean? Whether it's to serve a static file, so whether we send the static file back to the socket. So we need a routing engine that determines, I suppose you can just pass in the method, right? Or pass in the header, and then the separate engine will figure this out. So I reckon we create a little routing engine. Let's create a routing engine. And the routing engine will have determine static file route, or determine header routing engine. Then the header routing engine should return a file which can be read into a stream of data. For this occasion, I'm just going to return an integer for now. And what we need is a const. We need basically the response, the request, which is just a string, right? So please give me a string. In this case, I'm just going to put it in as a const char message. And the message should really just be called request, right? Const star message. Message. It's a buffer, actually. We need a char 124 buffer. for now, what we'll do is, what we do in here is we parse the routing message, and then we have a static file route, right? Routing engine. This should return a value. This actually returns a file, right? But I don't know how to specify. I think it's just a buffer or something. So this is technically a lie. But we'll just return an, let's just return void for now. And all we need to do is convert a buffer character to a string. We've done it before when we parse HTTP. We stream in here equals string method equals parse HTTP of a buffer. So we can just do this inside the function, right? So in the routing engine, let's const std string const standard library string. So let's pull in a string of memory of the request, and we'll convert it in here, right? So you pass that through, and then cool. Parse it in, and then convert string to stream, pull first word. Stream. Oh, I need stream, right? So convert stream, pull the first word, and then what we need to do is pull the parse HTTP header. Well, this will then call the routing engine, right? So I reckon we just, all we really need to check realistically, once we've converted it, I need to figure out how we mess around with this. So is string stream. CCP reference. We need to have a little read now. There's tons of functions we can do. Get character, unextracts, put character in a stream. There's tons of stuff we can do, right? If valid methods dot contains the method, there's tons of operators. Extract the formatted data operator. Peek reads the next character without extracting it, ungets it, unextracts, puts a character in the stream. Extract the given characters found. Extracts and discards all characters until the character is found. This is insanely useful. We can ignore and get line all the way. Get what we need, right? So we can ignore. Cool. So what we now need to do is the engine routing. Response sends basic HTTP requests. This is done. Routing engine, dev in progress. And how do we achieve this? Routing engine maps URLs, handlers. What we are doing now is read in the request HTTP, parse the header type. We've done the parsing of the header type. We now need to, once we've read it in, we need to grab the file path that is requested. Then convert file in file path and send file path and send converted file to file to current. Cool. My lunch break is finishing in 8 minutes, but I do need to get back to work. So what we managed to finish today was send the response back, which is quite easy, and fix some threading issues. And what we need to do for the next stream, or the next time I work on this, is with the routing engine, I need to map the URLs to handlers and return the static files. So I need to do this, which is what's dev in progress. The way we do that is by this. This is the steps I think we need to do. So we map the URLs to the handlers. The way we do this is we read the request HTTP, we grab the file path inside the request, convert the said file in the file path to something, I'm not sure what, and then we send the converted file back to the client, and then the client can then render that, right? So I need to figure out how to do that, which is cool. The way to do that is from once we've what I've done so far at least is we've converted it to a string, right? And I might also just push changes and say feature started routing engine, all the changed files, give it a push, unversioned files, leave that. Yeah, so we've managed to we've got to the point now we've converted the char array, right? The char message back to a IO stream or string stream, and I need to just figure out how to parse a string stream. The way we did that is I need to figure that out. Never done it before. In Python it's easy, but obviously it's not Python, it's C++. There's a couple functions here which I'll probably just use to like unextracts character, probably extracts discards. Yeah, we'll do ignore up until the slash, and then we'll get until we get line. Yeah, so we're gonna ignore up to the slash, and then we'll get line until this next space is found. And the reason why we're doing that is because if you actually look at the request header for the HTTP request, you start off with a backslash and you end at a space, right? So this is how we can get the directory that they need. The conversions down the line, I haven't thought about it, but we just need to parse this, which should be quite easy, trivial. Well, we'll see. C++, right? So I think that's it, really. Good hour session of coding. I need to go back to my day job and finish some tickets for work. But I think should be good for now. I don't just want to be an all-right engineer.